Division is a concept that is a struggle for actually many students in elementary school up through middle school and high school. And a lot of it, I think, stems from not understanding what it's about. So this is an attempt at that. So we're going to do some division with dots and boxes. Now we're going to just be using base 10, just the numbers that we all grew up knowing. In the next video, you'll see me doing division in other bases as well. So in this problem, I have the number 6,309 divided by 3. Now, we could do long division. I'm not doing that now. We'll do that also in a later video. But I want to get to the concept built is that when we divide by 3, there's actually two ways to think about that. One way is take the number 6,309 and divide it into 3 equal groups. All right. The other way to think about it is if I have the number 3, how many 3s does it take to make up the number 6,309? I think the second one is a lot more complex to figure out how many you would need. It's kind of like reverse multiple or guess and check on multiplication. So we are actually going to focus on the first one, which is groups of 3. All right, we're going to imagine, just for a moment, imagine dividing $6,309 up between 3 people. Okay, well, how would you do that? You might start with the thousands, 1,000 for you, 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 1,000 for you. In other words, we're putting the 6,000 first into 3 equal groups. So I'm going to illustrate that with the dots and boxes. So if you put 6, 3, 0, and 9 to get your final answer, you're just going to find groups of 3 in each of the place values. In the first place value, or excuse me, in the thousands place, I can say that because it's base 10. In the thousands place, we're going to ask ourselves, do we have a group of 3? Yeah, sure. We have actually 2 groups of 3. Now, I know I've circled dots before, but that was to like use a rule or explode. We're not doing that here. I'm just finding or locating groups of 3. And then I'm going to note how many groups do I have? 2 groups. So I have 2 groups of that, right? And then in the hundreds place, I have 1 group of 3. In the tens place, there's no groups of 3. There's no dots at all. And in the ones place, I have 3 groups of 3. So my answer is 2,103. In other words, 6,309 divided by 3 is 2,103. Now that works out really nicely because I have all these beautiful, perfect groups of 3. What happens if we don't have that? Let's take a look at an example. In this example, we have 9,007 divided by 4. Okay, remember, we're still doing groups of, but in this case, we're going to find groups of 4 rather than 3 like the previous problem. So let's put the numbers into the dots and boxes. All right, we have 9,000, so that'll be 9 dots here. And then 0, 0, and 7. Okay. In a different example, you might have dots in between, but that's 9,007. Finding groups of 4. Well, in the thousands place, we have a group of 4 and another group of 4. We have, in fact, 2 groups of 4, but we have 1 dot left over. Now, we can't just leave, that's 9,000. Imagine this is money. There's an extra $1,000 left. We don't want to just leave that $1,000. We want to break it into smaller parts so we can still figure out how to find groups of 4. So there is no groups of 4. So we're going to do kind of like an unexplode, right? We're going to move that dot back. Remember, it's base 10. So if we move it back or unexplode it, it will make a group of 10 dots to the right. Let me draw those out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still looking for groups of 4. Now I have a bunch of groups of 4. Well, actually, I have 2 groups of 4. So let's see. Let me circle those. 1 group of 4, 2 groups of 4. Notice I have 2 dots left over, but I have 2 groups of 4. Remember at the top, I'm keeping track of how many groups, 2 groups. All right, and this time I have 2 dots left over. I have a whole lot of unexploding to do. Unexplode that, move it over, unexplode that, move it over. Each one of those 2 dots will have 10 dots. So I have a bunch of dots to do. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? 10 and 10 is 20. Notice I drew them in rows of 4 to make it easier to circle. Now I'm looking for groups of 4 still. Got it. 1, 2, 3, 4, 5 groups of 4. All right. Then moving into the ones place, I have a group of 4, 1 only, and I have 3 left over. So what in the world is this extra stuff? What do we do with that? Well, at some point in elementary school, you learn how to go into the decimal place, but we're not there yet. We're just still dealing with whole numbers. This will be known as my remainder piece. remainder. In other words, what's left over, what I could not break into a group of 4 without breaking those into decimal pieces. So the way we would write our answers, we would say, well, 9,007 divided by 4 is equal to 2,251 with a remainder of a leftover amount of 3. And it's always valuable to remember how to check that. How can we check that? Well, you could multiply those two numbers together and then add the remaining 3 in to make sure you have the 9,007. One last example. Let's see what happens when we have a 2-digit number. Can we still pull this off? We actually can. Now, you might think at first, like, you got to be crazy, Mr. C. You're going for groups of 21. I am, but I'm going to visualize it differently with dots and boxes. All right. 21 is really 2 dots in the tens place and 1 dot in the ones place. So I'm actually, and rather than counting 21 dots, I'm going to look for groups of 2, 1. So let's put the dots into the box and see what happens. I have 4,315, so I have 4, 2, 3, 4, 3, 1, 2, 3, 1, and then 5. All right, and I'm looking for groups of 21. Well, obviously, in any box, there's not a group of 21. We're never going to have more than a group of 9. So I'm going to look for groups of 2, 1, and I can find those. So I can find one here. I'm going to pause for a second there so you can see how it's a 2 and a 1 next door to each other. And really, what place value am I finding that at? Is that a group of 21 in the thousands place, or is it in the hundreds place? Well, this may answer it. Well, first of all, it's in the hundreds place. And here's why. If you imagine the unexploding, if you were to unexplode these 2 dots, wouldn't that really be 21 dots? Because each dot would explode over or unexplode to make 10. You'd have a grand total of 21 dots in the hundreds place. So wherever it terminates, so that's one group there. There's another group there. That's 2 groups of 2, 1 in the hundreds place. All right, notice I have a dot left over. And I can't do the same thing here because if I circle those 2, that's not 2, 1, that's 1, 1. So it doesn't look like I have a group at all. I'm going to be stuck with the unexploding. So I'm going to unexplode those and move them over, right? It's going to make 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might notice I'm drawing those in groups of 2. And then again, I'm looking for, by the way, I forgot to write my 0 here. Now I'm going to look for groups of 2, 1 in the ones place. And we have some. Here's a group of 2, 1 right here. Here's a group of 2, 1 right here. 2, 1 right here. 2, 1 right here, and 2, 1 right here. In fact, that's 1, 2, 3, 4, 5 groups of 2, 1. And notice I have 1 dot unaccounted for. And there is no need to unexplode it because if I unexplode it, it'll just make a group of 10 dots in the ones place, and I can't do anything with that. I'm looking for groups of 2, 1. So this little dot over here is actually my remainder. Okay, so my final answer is 205 remainder. It's tempting to put 1, but it's not a 1. It's in the tens place, so it's 1, 0. Or in base 10, we just say remainder 10.